This is 10.3, geometric sequences and series. So geometric sequences and series have consecutive terms that have a common ratio. Think multiplication or division to get to the next number in the sequence. So if we look at example 1, for this one, I'm going from 1 to 2 to 4 to 8 to 16. So I'm multiplying by 2 every time. So my common ratio is 2. On the next one, let me do it different. Let's try this one. So in this one, I'm not sure how this works, but going from 12 to 36 to 108 to 324. So I'm multiplying by 3 every time. Then on the last one, here's a finger. Okay, I'm going from negative 1/3 to 1/9 to negative 1/27 to 1/81. So you notice that I'm multiplying by a negative every time. So I need a negative, and to go from 1/3 to 1/9 to 1/27 to 1/81, that's 1/3. So the top stays the same, but the bottom is by a third of time. So you're multiplying by negative 1/3. So the nth term of a geometric sequence, hold on, let me do some stuff. I want to see something. Oops, let's undo that. Okay. So, hold on, I want to see if something, if it shadows. Nope, that doesn't do it either. Okay. Sorry, I was just trying to see if I could do some highlighting, but I can't. So we're just going to do it the old-fashioned way. I'm going to do it with a pen, and I'll make this yellow, make it a little bit brighter yellow. Okay. So for my geometric sequence, I have a sub n equals a sub 1 plus r raised to the n minus 1. This should look familiar. You did this in Algebra 2 and even in Pre-Cal where we did exponential growth and decay. This is my starting point. This is my ratio raised to the n minus 1. So your a sub 1 is whatever the first term is in that particular sequence. Your ratio is going to be a number that's at the base of your exponents, so that's how you know what your ratio is, raised to the n minus 1. So I want to write the first 5 terms of the geometric sequence, whose first term is a sub 1 equals 3, and the ratio is 2. So this you don't really need the formula for. You can just, if you know that it's geometric, you start with 3, and then if you're multiplying by 2, that gives you 6. 6 times 2 gives you 12, 24, 48. There are my first 5 terms. So really, as long as you know that it's geometric, multiply. I want to find the equation for a geometric sequence with the first term of 20 and a ratio of 1.05. So this is my a sub 1. This is my r. So for part A, we're going to do, and again, for you to memorize the equation, and yes, you need to memorize them, I would just write it out over and over until you learn it. My a sub n equals my first term, which is 20, times my ratio of 1.05 to the n minus 1. You may not multiply these two numbers together ever. So that is my equation. And then if I want to find the 15th term, basically I just plug in 15, 1.05 to the 15 minus 1. And if you stick that in the calculator, you are going to get 39.60. Since you have 1.05, that's going to be a decimal. And yes, this probably would be on a calculator part of your test. Okay, I want to find the 10th term of a sequence, 5, 15, 45. So my first term is 5, and you're multiplying by 3 every time. So my ratio is 3. So my equation is a sub n equals a sub 1 times r to the n minus 1. So if I want to find the 10th term, I'm going to plug in 10 for n. My first term is 5. My ratio is 3 to the 10 minus 1. And again, you may not multiply the 5 and 3 together. Order of operations says I have to do the exponents first and then multiply by 5, and that gives me 98,415. Okay, 7, I want to find the fourth term of a geometric sequence. The fourth term of a geometric sequence is 125. So that means a to the 4th is 125, and a to the 10th is 125 over 64. So if I kind of do it graphically, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 1 ratio 2, 3, 4, 5, 6. So you're really doing 125. Now remember, you're multiplying these r's together. So you're doing r times r times r times r times r times r, which is r to the 6th. And that equals 125 over 64. So your r to the 6th equals 125 over 64 divided by that 125. And so if you do copy dot flip 125 over 64, change division to multiplication, flip the 125 over 1, the 125s disappear. You basically have r to the 6th equals 1 over 64. So if you take the 6th root of 1 over 64, you get your r is 1/2. Okay, so that's how you kind of do it graphically. But before I find, and I'm going to do it algebraically kind of on the next screen, so that if you don't want to write this all out, you can kind of do your pattern. So if I want to figure out what the 14th term is here in a minute, I'm going to have to go backwards and find the first term. So if I'm multiplying by 1/2 to go this way, that means I'm going to multiply by 2 to go this way, or divide by 1/2 to go that way. So that means this is 250, 500, 1,000. So my first term is 1,000. So in 2 screens, I'm going to do 1,000 as the first term to find the 14th term. But on the next screen, I'm going to do all of this stuff again algebraically. So like on the last, when we did arithmetic, we kind of said, okay, you do the y2 minus y1 over x2 minus x1. It's kind of like slope. Well, on geometric sequences, you divide. You do y2 divided by y1, and then you root it whatever that 10 minus 4 is. I'll show you what I mean on the next screen. So algebraically, you've got a to the 4th equals 125. A to the 10th equals 125 over 64. So we're going to kind of call this y1, y2. So think of it like this. You're doing y2 over y1, and you're taking the root of, and then this number in here should be the 10 minus the 1. The x minus the x2. Think of this as x2 minus x1. So x2 minus x1. So kind of think of it like that. You're doing whatever root of x2 minus x1 is in here, divided by y2 over y1. If you want to do it mathematically like that and not have to write it all out. But it will help you to write it all out, especially when I talk about geometric means. Just like arithmetic, if I say geometric means, and I say there's 3 of them between, let's say, 5 and 50, that means there's 5. There's 1, 2, 3. Oops. Let me make a break in there. And then 50. And it's the same thing. You multiply by r. So there is a place for doing it like we did on the last screen, where you write them all out and you figure out your ratios, because it's going to help you if you have questions about geometric means. So the second part of the problem was to find the 14th term of the sequence. And so when we went backwards, you had 125. We went backwards and got 1,000 as our starting term, and our ratio was 1/2. So my a sub n equals 1,000 times 1/2 raised to the n minus 1. So if I want to find the 14th term, I'm going to plug in 14, and that gives me 125 over 1,024. And since your original equation gave you everything in fractions, you want to write your final answer in fractions.